B. So formula A is called as substitution instance of another formula B if A is called as substitution instance of another formula B if A can be obtained by, or we can say A can be obtained from B by replacing some variables of B with the condition that same formula is substituted for same variable each time it occurs. So this condition is very important. What we have to do? We have to replace some variables of B with some formula, and it is condition that we have to replace same variable with the same formula each time it occurs. Then only A is called as substitution instance of B. Okay. So now look at this formula. B is given P conditional J and P. Okay. So here we have taken by conditional S for P in B. Means what? We have to replace this variable P from this formula B by using formula R by conditional S. So for that purpose, first of all we have to check how many times P is occurred in this formula B. So if you observe, P is occurred here twice. That's why we have to put this formula twice. Then you will get formula A. So A is called as substitution instance of B because we have formed this formula A from B by substituting some variables of B by any formula with condition same formula or same variable is replaced by same formula each time it occurs. So here R by conditional S, this is substitution for P. So formula A becomes R by conditional S, conditional J remains same, J, and again this second P should be replaced by same formula as R by conditional S. That's why A is called as substitution instance of another formula B. Okay. Are you getting this concept? Substitution instance? Hello? Have you understood what is meaning of substitution instance? Hello? Hello? Have you understood what is meaning of substitution instance?
Yes, ma'am.
Okay. Okay. So here one example is given substitution instance of P conditional negation Q, and these instances are who is speaking out? Hello. Hello. Is my screen visible?
Yes, ma'am.
Okay.
Yes, ma'am.
Yeah. So here we have to find substitution instance of P conditional negation Q. Okay. So here we can replace this variable P and Q. So if you observe the first formula, that is given as R and negation S conditional negation of J or M. Okay. So from this we can say that here P is replaced by formula R and negation S, and Q is replaced by formula J or N. That's why first is substitution instance of given formula. So likewise, if we observe the second formula, here P is replaced by R and negation S, and Q is replaced by R and negation S. So all these are called as substitution instance of given formula. So here consider this formula P conditional negation Q. Okay. So here what they have said, substitute P or Q for P and R for Q. Then what is the substitution instance? So we must replace this P by using formula P or Q. Conditional negation. Now Q should be replaced by R. That's why P or Q conditional negation R. This is a substitution instance of P conditional negation Q. Okay. So here we have to replace that given variable by given formula. Then only you will get substitution instance. So this was the concept of substitution instance. Now we have to see the next point as equivalence of formulas. So already we have seen this, how to recognize whether two formulas are equivalent or not. For that we have taken one note. Can you tell me what was that note? How to recognize whether two formulas are equivalent or not? How to recognize there are two different methods by which we can say whether two formulas are equivalent or not. Okay. So here a statement formulas A and B are equivalent provided A biconditional B is tautology. And conversely, if A biconditional B is tautology, then A and B are equivalent. So this is the way to check the equivalence of formulas. What we have to do? We have to find out biconditional between those two formulas. If A and B are the formulas, then if A biconditional B is tautology, then we can say that A and B are equivalent. Okay. So here this equivalence is represented by using this symbol. So and we can read it as A is equivalent to B. Okay. And this is the symbol for equivalence. Again, this equivalence is a symmetric relation. Symmetric means what? If A is equivalent to B, then B is equivalent to A. So this is the symmetric property. Again, second property, equivalence is a transitive relation. Means what? If A is equivalent to B and B is equivalent to C, then A is equivalent to C. So this is called the transitivity. So this equivalence relation satisfies these two properties. First one is symmetric and second one is transitive. Okay. So again, here we have seen some examples. Here I have to prove that P conditional Q, this is equivalent to negation P or Q. We already we have seen this formula that P conditional Q is equivalent to negation P or Q. Now we have to prove it by truth table. So first of all, we have to recognize how many variables are here in this formula. So P and Q, these are the two variables. That's why your truth table will contain 2:2. That is 4 possible combinations of truth values. So for P, TT, FF, for Q, TF, TF. Now for P conditional Q, what is the rule? If P is having truth value T and Q is having F, then only final value is F. Otherwise, it will remain true. Now check here. In the second row, P is having truth value T and Q is having truth value F. That's why final value is F. And for all other combinations, it will remain as true. Okay. Then in the next column, we have to find negation P. So whenever we have to take negation of any variable, if P is there, we have to write F in negation of that variable. That's why negation of P is containing truth value T. That's why negation of P is F. Again, T, F, F, T, F, T. So here we have taken negation of this column P as a negation P. Then negation P or Q. So here is negation P, here is Q. So or means what? If both are false, then only final value is false. That's why look here in this second row, both are containing values as F. That's why final value is F. F, F, F. And remaining combinations, it is true. Now check what is the value for P conditional Q and negation P or Q. So here we have to take biconditional between these two because what was the our definition for equivalence? If A and B are two formulas and then if A biconditional B is tautology, then only we can say that A is equivalent to B. So here take the biconditional between these two formulas, that is P conditional Q, this is the first formula, and negation P or Q, this is second formula. So what is the rule for biconditional? If both are having identical values, then final value is T, otherwise it is F. Now check, first value is T, T. So both are having identical values, that's why final value is T. Likewise, FF, again, both are having identical values, that's why final value is T. Again, TT, T, TT, T. Now check for the last column. Your last column is containing all the values as T. That's why we can say that this is a tautology. So given formulas are equivalent. So in this way, we can show equivalence between any two formulas. This is the first method. Now, again, there is another method. Here we can observe if you give the column number 1, 2, 3, 4, 5. Okay, so here we can say that column number 3 and 5 both are containing same truth values. Check here, TF, TT. That's why these two formulas are equivalent. This is second method. So by using any of these methods, you can prove the equivalence between formulas. Okay. Are you getting this? What is the equivalence of formula? Hello? Hello?
Yes, ma'am.
Okay. Now, in the next question, they have said, show that P conditional, Q conditional are this is equivalent to P conditional negation Q or R. This is equivalent to P and Q conditional R. Okay. So here we have to prove the equivalence between these three formulas, as these three formulas are equivalent to each other. So we will take each formula. First one is P conditional, Q conditional R. So here we can replace this Q conditional R by its equivalent formula as negation Q or R. We have already seen this formula, how to convert this conditional into an equivalent formula. So Q conditional R, this is equivalent to negation Q or R. So put this value for this Q conditional R. So it will give you P conditional negation Q or R. And that is the second formula. That's why we can say that yes, these first and second formula, these two formulas are equivalent to each other. So now we have to prove this is equivalent to third formula as well. Okay. So up till now we have seen first two formulas are equivalent. So again we can convert this second formula as we have to remove this conditional. That's why we have to take negation of first variable or second variable as it is. So negation of first variable, negation of P, or we have to keep this second formula as it is as negation Q or R. Now check here what we have got, negation P or negation Q or R. So we can take this negation which is common outside. That's why negation of P and Q or R. Now this negation is applied to this whole bracket P and Q. Okay. So again, if you check, we can convert this one into an equivalent formula as P and Q conditional R, and that is our third formula. Now check. In this way, we have proven the equivalence between these three formulas. Are you getting this? How to prove equivalence? Hello? If you have any doubt, you can ask me. Later on, it is not possible to repeat all the things again. So I hope you have understood. Now, next question. Again, they have said, show that this formula is equivalent to R. So this question is very important as they have asked this question in near about in each and every question paper. Okay. So see here, what is the given formula? Negation P and negation Q and R, or Q and R, or P and R. Okay. So first we can combine these two negations in one bracket as negation P and negation Q, and we can take this and R outside. Okay. Or Q, again, if you observe this second and third bracket, and R is common between these two. That's why Q or P will remain in one bracket and then and R. So we can say that this and R is applicable for this whole bracket for Q or P. So again, here we can take this negation R, which is common between these two brackets outside. That's why negation P and negation Q, or Q or P, and for this whole bracket we have taken this negation R outside. Means what? This and R outside. So this and R is applicable for this whole bracket. Okay. Again, from these two terms, negation is common, so we can take that negation outside. So negation of P or Q. We have taken this negation, that's why this and becomes or. That's why negation of P or Q, or P or Q. And for this all term and R is there. Okay. So again, what is the value for P or negation P? It is true. Likewise, negation of P or Q, or P or Q, its value is true only. That's why P and R. So again, the final value for this formula is R, because value of this one will be depend upon value of R. If you consider the value for R is P, then you will get answer as P and T as T. If you consider value for R as F, then T and F as F. Means what? Value for your this formula will depend upon value of R. That's why final answer is R. So in this way we can prove this equivalence. So likewise you have to solve examples based on equivalence. When they say that, show that, at that time you have to prove that without formation of truth table. You have to prove that equivalence without formation of truth table. So next question, show that P or Q and negation of negation P and negation Q or negation R, or negation P and negation Q, or negation P and negation R is a tautology. So this whole formula we have to prove this one is a tautology. So here we have to apply the De Morgan's law to solve this example. So what is the De Morgan's law? So they have given here negation P and negation Q. This is equivalent to negation of P or Q. That we have already used this formula. If you are going to take this negation outside the bracket, then negation of this and becomes or. So negation of P or Q. So likewise, negation P and negation R, this is equivalent to negation of P or R. Okay. So again, negation P and negation Q, or negation P and negation R. So again, from these two brackets, we can take negation outside. So if you observe the first bracket, we are going to take this negation outside. So negation of P or Q. This is the first bracket. Or again, we have to take negation common, which is common between two terms. That's why we have to take it outside as negation of P or R. Okay. So again, now between these two terms, negation is common. So we can take that negation outside as negation of P or Q. Now this or becomes and, because we have taken this negation outside, and P or R. So here we have simplified each and every term. Now one term is remaining as negation of negation P and negation Q or negation R. Okay. So here again we can take this negation outside from these two terms as negation of Q and R. Here or is there, but if you take this negation outside, then this or becomes and. So negation of negation P and negation of Q and R. Now we have to apply this negation to this bracket. So negation of negation P means what? P only. This and becomes or. Again this negation will get cancelled. So P or Q and R. So we can apply here distributive law as P or Q as one bracket and P or R. So again we have to show that this is a tautology. So how we can show this one is a tautology? Hello. So here we can show that this term, if you observe this whole term as for this P or Q, we can keep this term as it is as P or Q. Again second one, for this second term, what we have got simplified form as P or Q and P or R. So that we have to put here P or Q and P or R. Okay. So again first term is P or Q and second term is P or Q and P or R. So here is repetition of term P or Q. That's why we can keep that terms once. That's why P or Q and P or R. This is simplification up to this bracket, up to second term. Now, or this second, third and fourth term. So for this, we have got simplification as negation of P or Q and P or R. Now check here. This is the first bracket or negation of this is second bracket. So if you observe, these two brackets are same. So we can replace this bracket by P, variable P. So P or negation P, it will give you answer as P. That's why final answer for this formula is P. So we can show that this formula is a tautology. Have you got this question? Hello?
Yes, ma'am.
Okay. So now, next point is a duality law. So, what are the duals or what are the dual formulas? So, two formulas A and A star are said to be duals of each other if either one can be obtained from other by replacing and by or by and. So this is the one condition. Suppose A is a formula and we have to obtain its dual which is represented by A star, then we have to replace and by or by and. Again, if your formula A is containing some special variables like T or F, then in order to obtain the A star, that is its dual, we have to replace T by F and F by T. Then only we can say that A and A star are duals of each other. Very, very simple concept. Just we have to replace and by or by and, or if it is containing some special variable like T or F, then if T is there, then we have to replace it by F. If F is there, then we have to replace it by T. Like this. So here some questions are given. Write the duals of P or Q and R. So here, in order to obtain its dual, we have to replace this or by and by or. So first answer is P and Q or R. Check here, P and Q or R. So this is the dual for first formula. So in the second formula, T is there. So we have to replace this T by F. So P or Q and F. So this is the answer for second one. And for third one, negation of P and Q or P and negation of Q or negation of P and Q. So this is the answer for third formula. So here Hello, am I audible?
Yes, ma'am.
Okay. Sorry, because of network problem, I got disconnected. So here we are looking for this example based on implication. So here we have to prove implication between these two formulas as P and Q logically implies to P conditional Q. Okay. So first of all we have to analyze how many columns will be there. So first column for variable P, second one is for variable Q, then
Ma'am,
Ma'am,
we have
screen
screen
is
to,
not
time.
visible.
okay. I will represent it once again. Now check. Is it visible now?
Yes.
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 Okay. So here, first column is for variable P, second column is for variable Q, third one is for P and Q, then next one is for P conditional Q, then we have to show the logical, or what we can say, the conditional between these two formulas as P and Q conditional, P conditional Q. Okay. So first one for variable P, we have to take values as PPFF for Q, PF, PF, and now we have to find out value for P and Q. So this is the conjunction. So when both P and Q will have put value T, then only you will get final value as P. Otherwise it will remain false. So for first combination only you will get put value as P. Now, next one is P conditional Q. So, P and Q. So, we have to check conditional between these two. If P is having put value T and Q is having put value F, then only you will get final value as F. Otherwise, it will remain as true. That's why only for second combination T F you will get final value as F. Now, in order to prove this implication, we have to take conditional between these two formulas as P and Q, this is the first formula, and P conditional Q, this is the second formula. So again check whether TF is there. So first value is T. Now check whether second value is F. No, again that is T. So there is no any combination that gives us TF. That's why all the values are true. So here we can say that P and Q, conditional P conditional Q is a tautology. That's why P and Q logically implies P conditional Q. Okay. So this is for implication. So likewise we can solve the example. So again here the second example is given, that is also containing two variables as P and Q. So we have to form the columns. First column is for variable P, second column is for variable Q, third one is for Q conditional P. Now last one will be P conditional Q conditional P, because we have to prove here implication. So again, values of P and Q we have written here as PPFF and TFTF. Now we have to take conditional between variables Q and P. So first of all we have to check the column for variable Q, then for P. So now check whether TF is there. Any combination of TF is there. So first Q is containing first value as P. Now check whether P is having value as F. No. That's why it will give you value as T. Now again check for Q where T is there. Now in the third combination of Q, T is there, and for P its value is F. So for this combination TF you will get final value as f, and then for remaining values it is t. Now again we have to take conditional between these two given formulas as p conditional, q conditional, p. So again for this p we have to check whether TF combination is there. Now first value of P is T. Second, again Q conditional P, it is T. So check whether TF combination is there. No. That's why all the values in the last column are T. So again, here we can write the statement as conditional between given formulas is tautology. So P logically implies Q conditional P. So this is the concept of implication. Do you have any doubt regarding these points? Have we understood what is the implication? How to prove? Hello? Do you have any doubt regarding this?
No, ma'am.
So next concept is functionally complete set of connectives. So what are the functionally complete set of connectives? We have already said how we can recognize the functionally complete set of connectives. Till now we have seen five connectives as negation, then conjunction, disjunction, conditional and biconditional. Okay. So all the time it is not necessary to take all these five connectives. So we can form a set of connectives, and by using the connectives from this set, we can convert any formula into its equivalent formula. That's why that set is called as functionally complete set of connectives. म्हणजे काय प्रत्येक वेळेस आपल्याला ते सगळे कनेक्टिव्ह यूज करायची गरज नाहीये. आपण असे सेट फॉर्म करू शकतो ज्याच्यातून व्हेरिएबल्स कनेक्टिव्ह घेऊन आपण कुठला पण फॉर्म्युला त्याच्या इक्वलंट फॉर्म्युला मध्ये कन्वर्ट करू शकतो. So that set is called as functionally complete set of connectives. So like friends, here some examples are given. First example they have given, write an equivalent formula for this given formula which does not contain biconditional. Means what? From this formula we have to remove this biconditional. So P and Q conditional R and R conditional Q. This is the removal of this first biconditional, or again we have to remove this second biconditional as R conditional P and P conditional R, because we already known that P biconditional Q, this is equivalent to P conditional Q and Q conditional Q. So same formula we have applied here to remove this biconditional. Okay. Now check here whether this formula is containing any biconditional. No. So here we have converted this given formula into an its equivalent formula which does not contain any biconditional. Okay. Now in this second example, they have asked write an equivalent formula for P and Q biconditional R which contains neither biconditional nor conditional. This what we have to form an equivalent formula which will not contain any biconditional as well as conditional. So can you tell me how to solve this example? How we can convert this formula into an equivalent formula which does not contain any biconditional as well as conditional? Okay. So first of all, tell me how we can remove this biconditional. What will be the equivalent formula after removal of this biconditional? Take 2 minutes, think on it, and tell me your answer. Hello. So what is the equivalent formula after removal of biconditional? Apurva. Apurva Kadam. Are you here? Hello. Roll number 16. So what is the answer after removal of biconditional? Unmute your mic and tell me answer. Hello. What is the problem? Have you understood this?
Yes, yes, ma'am.
Then why you are not answering?
If P is biconditional of Q, then P is equivalent to Q and R is equivalent to Q.
What? I'm not getting. I said that remove biconditional from this given formula. This one. From this formula. P and what is the next bracket?
Negation Q or R.
No. I just want to remove biconditional. Then in the next step, we will remove conditional. So first of all, tell me. Yes.
Q conditional R and R conditional Q.
Yeah. Q conditional R and R conditional Q. So after that, we have to remove the conditional as well. That's why P and we have to remove this conditional. That's why negation Q or R and negation R or Q. Now check here. In this formula, there is neither biconditional nor conditional. So this is an equivalent formula of given formula. Okay. So again, P and Q, this is equivalent to negation of negation P or negation Q, and P or Q, this is equivalent to negation of negation P and negation Q. Okay. So here we can say that using these two sets, that is first set is and negation, second set is or negation. So using these two sets, we can convert any formula into its equivalent formula. That's why these two sets are called as functionally complete set of connectives. So keep in your mind that only these two sets are functionally complete set of connectives. So if you observe negation only or set which is containing only conjunction or only containing disjunction, these are not functionally complete set. As well as any set which is containing conjunction as well as disjunction, these are also not functionally complete set of connectives. So here, up till now, there are only two functionally complete set of connectives. So first set is conjunction and negation, and second set is containing disjunction and negation. Now, the last point from this chapter is other connectives. So again, in these other connectives, we have to see three connectives. First one is XOR, second one is NAND, and third one is NOR. Okay. So first, we are going to see what is the exclusive or you can say this one as XOR. Okay. So if P and Q be any two formulas, then the formula P XOR Q, this is the symbol for XOR, P XOR Q, in which connectives XOR is called as exclusive OR, is true whenever either P or Q but not both is true. Means what? How we can find the truth table for this? If we can say that if both P and Q are having identical values, then final value is F. If both are having different values like TF or FT, then final value is T. That's why truth table for this exclusive or for these combinations of P and Q is FTTF. Now, in the first row and last row, both are having identical values. That's why final value is F. In the middle, it is having different values. That's why final value is T. So, whenever identical what was the truth table? If both P and Q are having identical values, then only final value is P. For other combinations, it will remain 4. So we can say that this is the exactly opposite to biconditional. That's why we can say that P XOR Q, this is equivalent to negation of P biconditional Q. Okay. Here, why we have taken negation? Because this is opposite to truth table of P biconditional Q. Again, this is satisfying some properties. First one is a symmetric property as P XOR Q. This is equivalent to Q XOR P. So this is called as symmetric property. Next one is a associative property. So for this associative property, we have to just change the brackets. So P XOR Q, this is the first bracket here, XOR R. So we can say that this is equivalent to P XOR Q XOR R. So here we have to just change the bracket. Third property is for distributive. So how we can apply the distributive law? P and in bracket Q XOR R. So here we have to apply this P and over this bracket. That's why P and Q, this will be one bracket, XOR P and Q. So this is the distributive law. Now next one, P XOR Q, this is equivalent to P and negation Q or negation P and Q. Why this formula is given here? Because we have seen if both P and Q are different values, then only you will get final value is T. That's why now here P is having truth value is T, Q is having F. This one P and negation Q. Then only you will get final value as T. Or second combination negation P and Q. Then only you will get final value as T. That's why P XOR Q, this is equivalent to P and negation Q or negation P and Q. We have taken this formula from these two rows. So here P is written for these two combinations. For first P, value of P is T. That's why P and negation Q, because value of Q is F here. So this is the first bracket or negation P and Q. Again, P is here. That's why negation P and Q. So this formula is built up from this truth table. Have you understood what is the XOR? If different values are there, then only final value is T. Otherwise, it is F. Now, two more other connectives are there. First one is NAND. So, NAND, its name itself suggests what is a NAND means what? Not and AND. That is NAND. Not plus AND. So here that NAND is represented by this upward arrow. So if you take any two formulas P and Q, the NAND between these two is represented by P NAND Q, and this is equivalent to negation of P and Q. What we have seen, NAND means what? It is combination of not and AND. Okay, so not, this negation will represent not, and we have to take combination of, or we can say and of these two variables as P conjunction Q. So negation of P conjunction Q. Likewise, NOR is a combination of NOT and OR. That's why NOR. So this NOR is represented by downward arrow. So if there are two different formulas, P and Q, the NOR is represented as P NOR Q. And this is equivalent to negation of P or Q. Okay. So this is the concept of NAND and NOR. Again, here we can say that this NAND and NOR, these are duals of each other. So here NAND and NOR are the duals of each other, and we have seen the set conjunction and negation, disjunction and negation. These are functionally complete set of connectives. So what is meaning of this and negation? This is NAND only, and OR and negation, this is NOR only. That's why we can say that this NOR and NAND are minimal functionally complete set or minimal set, because this NAND is from and NOT. Okay, so already we have seen that and NOT, these are the functionally complete set. Again, this NOR is from OR and NOT, and this OR and NOT is already functionally complete set of connectivity. That's why these two sets, NAND and NOR, are called as minimally functionally complete set or minimal set. Okay. So here some equivalences are given. P NAND P means what? We have to take negation of P and P. How we can write its equivalent formula? If we want to remove this NAND, we have to take negation of P and P. So again, if you apply this negation over this bracket, you will get negation P or negation P. So what is the answer for negation P or negation P? This is negation P only. That's why this formula is equivalent to negation P. Again, here second formula is given P NAND Q NAND P NAND Q. So what is meaning of this P NAND Q NAND P NAND Q? This is equivalent to if you want to remove this NAND, you can take negation of P NAND Q and P NAND Q. So again, what is the meaning of P NAND Q and P NAND Q? This is just like P and P. So we will get answer as negation of P NAND Q. So again, in order to remove this NAND, you have to take negation of P and Q. So negation and negation will get cancelled. You will get answer as P and Q only. So likewise, you can prove the equivalence after removal of this NAND. So same formulas are applicable for NOR. So instead of this and, you have to just replace it by OR. So if you consider the first formula, first one is P NOR P. So how we can remove this NOR? We have to take negation of P or P. So again, apply this negation over this bracket as negation P and negation P. So again, negation P and negation P, this is equivalent to negation P only. So likewise, you can form an equivalent form after removal of this NAND and NOR. So here some properties of NAND and NOR are given. So first property is commutative property. So P NAND Q, this is equivalent to Q NAND P. Okay. Again, P NOR Q, this is equivalent to Q NOR P. So this property is called as commutative property. Now second, we have to check whether this is satisfying associative property. So if you want to check, we have to change the brackets. If both formulas are given same result, then only we can say that this is satisfying associative property. Now consider first formula as P NAND Q NAND R and second formula as in bracket P NAND Q outside the bracket NAND R. If these two formula gives us same result, then only we can say that this NAND is satisfying associative property. So take first one as P NAND in bracket Q NAND R. So first of all, we have to remove this NAND from this bracket. So P NAND, in order to remove this NAND, we can take negation of Q and R. Okay. So here we have removed this NAND. Now we have to remove this NAND. That's why again negation of P and negation of Q and R. Okay. Now here we have removed both the NANDs. Now we have to apply this negation over this bracket as negation P. Now and becomes OR. This negation will get cancelled. Q and R. Okay. So for this bracket or for this first formula, we have got answer as negation P or Q and R. Okay. Now check for the second formula. Here bracket is applied to P NAND Q. Okay. So first of all, we have to solve this bracket. So remove this NAND. So after removal, you will get formula as negation of P and Q. Again NAND R. So now we have to remove this NAND. So again we have to take negation of this whole term and we have to replace this NAND by AND. So negation of negation P and Q and R. Again we have to apply this negation inside the bracket as negation will get cancelled. You will get answer as P and Q. Now, when you will apply this negation to this and becomes OR and negation R. Now check whether answer for these two formulas is same. No, the answer is different. These two formulas are not same. That's why here you can say that NAND is not satisfying associative property or NAND is not associative. So likewise, we can prove this one for NOR as well. So NAND and NOR are not satisfying associative property. They are just satisfying commutative property. Hello? So here,
Yes, ma'am.
we have completed a revision of first unit. So do you have any doubt regarding any point? Because we have revised this topic second time. So hereafter, I think I am not going to revise it again. So if you are having any doubt related to any point, you can ask me. We will discuss it here.
Hello, ma'am. Second, repeat once again.
Which one? This associative?
Yes, ma'am.
Okay. So, what is the meaning of associative property? If there are three variables, P, Q, R, then we have to check the parenthesis for these three. Okay. So, likewise, here three variables are given and operation between the in bracket Q and R. So this is the one formula. Now, in order to say that whether this is satisfying associative property or not, we have to change the bracket. Now check here, bracket is in between Q and R. So now we have to change the position of bracket. So we can take bracket as between P and Q as P NAND Q. Okay, and NAND R. Okay, so here we have constructed two formulas by changing the brackets between variables. Okay, so now solve the first formula, and that formula is P NAND Q NAND R. So first of all, we have to solve this bracket. So in order to solve this bracket, we have to remove this NAND. So how to remove it? We have to take negation of Q and R. So here we have written that and P NAND as it is. Now we have to remove this NAND. So negation of P and negation of Q and R. So whenever we are going to remove this NAND, how to remove the NAND? We have seen what is the equivalent formula for that. If the NAND remove करायचं असेल तर काय करायला लागेल? Negation of these variables. So negation of P and Q. This is the equivalent form. That's why here we can say that in order to remove this NAND, we have to take negation of P and negation of Q and R. Okay. So now, up till now, we have removed these two NANDs. Now, we have to apply this negation inside the bracket as negation of P. Now, negation of AND. This AND becomes OR. So, OR. Now, this negation will get cancelled. Answer is Q and R. So, simplified form for this first formula is negation P or Q and R. Okay. Now, again we have to check for the second formula which we have constructed, and that is P NAND Q NAND R. So, first of all, we have to remove this NAND from this bracket. So, how we can remove? We have to take negation of P P and Q, and this NAND is as it is. So in the second step, we are going to remove this NAND as well. So again take negation of first term and second term. So negation of, what is the first term? Negation of P and Q, and second term is R. So now apply this negation inside the bracket. So negation will get cancelled. You will get answer as P and Q. Now this and becomes OR because we are going to apply this negation and negation R. Now check whether these two formulas are same after conversion. No, these two formulas are not same. So here we can say that this connective NAND is not associative. Have you got it? Just you have to just apply the formula or definition for NAND. Have you understood?
Yes, ma'am.
Okay. So likewise, here we have proved this for NOR as well. So NOR is also not a associative. So check here what we have written. P NOR, Q NOR R. This is the first formula. Now we have to change the bracket. So after changing the bracket, you will get second formula as P NOR Q NOR R. So we have to check whether these two formulas are same. If it is same, then we can say that NOR is a associative. If it is not same, then we can say that NOR is not a associative. So first formula is P NOR Q NOR R. So first of all, we have to solve this bracket. So we have to remove this NOR. So what is the definition for NOR? P NOR Q. This is equivalent to negation of P or Q. So same formula we have to apply here for variables Q and R as negation of Q or R. Now this first term remains same as P NOR. Now in the second step, we are going to remove this NOR. So again, negation of P or negation of Q or R. So now apply this negation or this bracket as negation P or becomes and negation will get cancelled, then Q or R. So this is the simplified form of this first formula. Now check for the second formula. Second formula is P NOR Q NOR R. So, so we have to keep this NOR as it is. So in the second step, we are going to remove this NOR as negation of first, we can say first term or second term. So negation of first term is negation of P or Q, or second term is R. So now we have to apply this negation or this bracket. So negation will get cancelled. We will get answer as P or Q. Now this or becomes and negation R. So this is the simplified form for this second formula. Now check whether these two formulas are same. First formula is negation P and Q or R, and second formula is P or Q and negation R. So these two formulas are not same. That's why we can say that NOR is not a associative. Have you understood now? Hello? Okay. So here we have completed revision of unit number 1.
Yes, ma'am.
Give me presently. After that, we have to solve one quiz. I will send you link for the set. You have to attend that quiz. And time duration for quiz is 20 minutes. 10 questions are there. So you have to complete it within 20 minutes. Presently, roll number 1. Roll number 2.
Yes, ma'am.
3. 4.
Yes, ma'am.
Yes, ma'am.
5.
Present, ma'am.
6.
Present, ma'am.
7. Roll number 7. 8.
Present.
9.
Yes, ma'am.
10.
Present, ma'am.
11. 12.
Present, ma'am.
13.
Present, ma'am.
14. 15.
Present, ma'am.
Present.
16. 17.
Present, ma'am.
18.
Ma'am, 7 present.
Okay. Roll number 18. Okay. 19. 20.
Yes, ma'am.
21.
Yes, ma'am.
Yes, ma'am.
22. 23.
Present, ma'am.
Present, ma'am.
24.
Present, ma'am. Roll number 24 is present.
Okay. 25.
Yes, ma'am.
26.
Yes, madam.
27. 27. 28.
Present, ma'am.
29.
Yes, ma'am.
30.
Present, ma'am.
31.
Present, ma'am.
32.
Present, ma'am.
33. 34. 35.
Present, ma'am.
36. 36. 37.
Present.
38.
Present.
39.
Present.
40.
Present.
41. Okay, 40 is present. 41. 42.
Present.
43. 44. 45. 46. 47. 48.
Present.
49.
Present.
50.
Present.
51. 52. 52. 53.
Yes, ma'am.
54.
Yes, ma'am.
55. 56,
Yes, ma'am.
57,
Yes, ma'am.
58, 59, 60,
Yes,
61,
ma'am.
okay, 61,
Present, ma'am.
62,
Present, ma'am.
63, 64, 65,
Present, ma'am.
okay, 66,
Present, ma'am.
67,
Yes, ma'am.
68, 69,
Present, ma'am.
70,
Present, ma'am.
okay,
Hello, ma'am.
हाँ
मॅम 58 होता बट डिस्कनेक्ट झालाय ते आता मला मेसेज आलता ते नेटवर्कमुळे पाऊस चालू आहे त्याच्यात तिथं त्यामुळे डिस्कनेक्ट झालाय चला आपण घ्या
okay.
Ma'am, 22 is present.
Check our WhatsApp group. There I have shared link for today's quiz. So attend it. Hello. Have you got the link?
येस please.
Okay. So after 20 minutes, your time will be over. So solve it fast.
Hello?
Hello?
2 is present, ma'am.
Who is present? Okay.
No, ma'am.
I will correct it.
Present is
Oh,
ma'am.
yeah. Are you solving this quiz?
Hello, ma'am. ते ओपनच होत नाहीये.
ओपन होत नाहीये.
हा.
मेसेज काय आलाय स्क्रीनवर?
You need permission असं म्हणते.
I will check.